Inequality x greater than or equal to 3. Second inequality is that x is greater than 1. Do I need both to be fulfilled at the same time? Or just one can already? No, I need both. Look at the question. Simultaneous inequalities. And they even said and. See the word and over here? I need both to be satisfied at the same time. Okay? So we use a number line to help us. The number line, numbers of interest will be obviously 1 and 3. So your number line is actually your x-axis over here. You can look at it as your x-axis, you have the x over there. So plug in your two number arrows for the two inequalities, and we are looking for the region where they overlap. So let me edit this a little. I want this arrow to be longer. Okay, we see that over here we've got 3 regions. If I want, I can divide it into 3 regions. Region number 1, region number 2, region number 3. In which region do I have both inequalities satisfied at the same time? 3. So my answer is region 3. The question is, do I include the value 3 or not? Do I?
Yes.
Yes, right? Because in both inequalities, the number 3 is accepted. So this over here is just a working. Okay, it's not the final number line yet. My final number line is going to look like this. In black will be my final number line, x, 3. Okay, this represents the region 3 over here. Alright, so what is my final answer then? What is my final answer for x? X is greater than or equal to 3. Now this is my final answer. Okay, so working wise, this is what we are going to expect.
So how to write the final answer? Just write x more than 3.
More than or equal to 3. This is the final answer.
Then you put
The 2 dashes. You can use that to show the marker that this is my final answer. You can just put A and S stuff. Okay? Because the problem is, if you stop here, let's say you stop over here, I see 2 answers, x greater than or equal to 3, x greater than 1. I don't know what's your answer. Are you telling me to choose one? Or are you telling me that one of it is or both are the answers? You know what I mean?
so
Yes.
must draw the final number line.
Yes, I want the final number line. This is just a working only. Okay, there's a question over there, yes? Do we have to what? Include other values? No need. Only for my final answer line, only the number 3 is relevant to me. Everything else is not important, right? So I only need 3 lah. Just like in my working, only 1 and 3 are important to me. Everything else not important, don't need show. Okay? Next, we've got question 1H. What V has for us. We've got 2 linear inequalities again. Let's tackle the first one. How did he get from here to here? What did he do? What?
I times 12.
You times 12 on both sides?
Yes.
Yes, that is correct. Okay, so multiply by 12 on both sides. Since we are multiplying by a positive number, then there isn't any sign flipping. Okay, so he continued and got x greater than or equal to negative 7. On the other side, he multiplied by 7 on both sides. Got another inequality, x less than negative 1. Transfer them onto our number line. So one small area for improvement, put a dash over here so I know where exactly is your negative 7 and negative 1. Okay, he skipped the working in between. It would have looked like this. This is our x, negative 7, negative 1. Negative 7 is less than negative 1, so it must be on the left hand side. Since it is greater than or equal to negative 7, I get one arrow on this side. Since it is less than negative 1, I get another arrow on this side. I am looking for the region of intersection, which in this case will be which region? 1, 2 or 3? 2. Okay, so some people they shade it this way and then they transfer the answer down. Are we including the value negative 7?
Yes.
Yes, right? Negative 7 is found in both linear inequalities. What about the number -1? Is it found in both? No, it is not. It is only found in this inequality. It is not found in this second inequality, which is why our final answer, we do not include the value of -1. Can? Okay, so that's for question 1. Let us move on to question 2. A. This is the correct. So the final correct answer. This is just a number line. We have x in the middle. Okay, when we see a number line that looks like this, I've got x ranging from -7, so I shaded, to -1. So -7 on this side, -1 on this side. What is the inequality sign? It will look like this. Okay? When I am describing a range that has two endpoints, -7, -1, my inequality sign, I'll be using either one of these. I will not go the other way, because small number on the left, big number on the right. So let me tell you a common mistake. Okay, the one in blue, I will not accept, because I want a smaller number on the left. Okay? So now question 2. A. What do you think for 2A? Tell me which part. First step looks correct. Correct. This is also correct. This is also correct. What about this? What do you do over here, Darius? This circle step. Divide by -7 on both sides. Do you know why your friends are saying it is not correct? What? You didn't switch the sign. Do you need to switch the sign? Do you need to? Yes, right? When you're dividing by negative or multiplying by negative, you need to switch the sign. Okay? So suppose he didn't need to do that. Suppose this is correct. What about the number line?
Then there should be a x value there.
Yeah, I've never taught you this. I don't know what this is. If your inequalities are correct, then you should be doing this. Then I also don't need this little line over here. This should be x. Okay? If it is correct. But your inequality is wrong, so the number line will also be wrong. Okay, so this should have been less than. So drawing our number line, we have x, we have 2 and 23. X is less than 2, x is less than 23. So again, you see that it is divided into 3 regions. Region number 1, region number 2, region number 3. Which side, which region satisfies both inequalities? 1, right? Do I include the value 2? Yes or no? Are you sure yes? Okay. So this is x, this is 2, and this is my answer for number line. So my final answer will be x less than 2. Sorry? They never tell you to draw number line. Okay, if they didn't tell you to draw the number line, are you able to go from here to here as your final answer?
We practice.
Are you able to?
We practice.
Some can, some cannot. If you can, good. If you cannot, then you use the number line to help you. Because some people can look at it. Oh, x must be less than 2. X must be less than 23 as well. So of course x must be less than 2 and I cannot include 2. Some people can do that. Fine, go ahead. If you cannot, use the number line. It will always help you. Next question, we've got 2B. Question 2B. Okay with his work? First one, second one looks fine. All these look correct. Right? Are they all correct? Yeah, okay, let's go to the number line. Okay, this is correct. Where is the final number line? Question didn't ask for it, but if I want the final number line, do you know how to draw it?
Yes.
Zachary, do you know how to draw it? Yes, okay, you look like this. X, negative 14 over 3. Right? Okay, final answer. Correct or wrong?
Wrong.
Why wrong? Zachary, you say wrong, right? Why wrong? So correct or wrong? Smaller number on the left. Which one is smaller? Negative 14 is smaller, right? See, your number line already shows that negative 14 should be on the left, this one should be on the right. Why you invert everything over here? Right? And didn't I just say a while ago that I don't want it this way? I wanted it this way. Can? Okay. Next question. F. Familiar with? Very popular test question. Here we have two inequalities combined into one. So I like to box them up this way to help me work on them separately. Okay, that's the green one and this is the blue one. So just copy them down. X minus 2 over 2. Okay. Multiply by 6. What do you do from here to here? Cross multiply.
Times 4. Okay, just times 4.
Can cross multiply or not? Can we do a quick check? What if my question looks like this? X plus 2 over negative 3, x minus x plus 8 over 5. What happens like this? Can cross multiply or not?
Cannot.
Why cannot? What do you mean must be equal sign? So here can cross multiply or not? What will we be doing if we are cross multiplying? Times negative 15. Okay, so if you try to cross multiply, you will have something like this, right? 5 times x plus 2 greater than or equal to negative 3 times x plus 8. Am I right? Is this what you do if you cross multiply?
Yes.
Is this correct? Why not? So will this then be correct?
Yes.
Confirm? So do you see that I didn't teach you anything like this because of this problem, which can be solved if we want to solve it. Okay, but I leave it to you to go and verify which is correct. Is it like this? Or is it like this? You know how to test it out? You just need to multiply both sides by negative 15. Here also multiply by negative 15. Because when you multiply by negative 15, without regard to the sign over here first, so here you multiply by negative 15, you will end up with 5 here, right? Negative times negative gives you positive. So over here when you multiply by negative 15, then you will end up with a negative 3, isn't it? Now what happens to the sign? It should change. Because you are multiplying by negative 15. Okay? So this is what happens when you try to cross multiply. You cannot leave it as this because you'll be wrong. Then, what happens if the question looks like this? What happens if this is the question? Do you want to cross multiply? You want to cross multiply? Okay, when you cross multiply, then you get a 5 over here, you get a 3 over here, right? What happens to the sign? Same? Confirm? You are right. So do you therefore know when to change the sign? You sure? Then you better be correct. So what if the denominator is now an unknown? Let's say it is x. Then can cross multiply? Why cannot? X can be negative, right? What happens if x is negative? Then if it is positive? Yeah, so I don't like to do it this way. I like to work on it the way that I am sure will be correct, which in this case, I want to multiply both sides by 4. Because 4 is a positive number, I don't need to change any sign. On the left hand side, after I multiply by 4, I get 2x minus 2, less than or equal to 3x plus 7. So we get 2x minus 4 less than or equal to 3x plus 7, and everything else should be the same. X, okay, this part is correct. So x is greater than negative 11. What? Shouldn't be lah.
Very rare.
Yeah. Okay, so now we have the number line. One improvement, make the circles bigger. Okay, so that I can see clearly. X is greater than negative 11, x greater than 6. So this is our final answer. Okay? And we have one final question. 4. So split it out into 2 equations, 2 linear inequalities. Do them separately. Only at the last part that you combine them into your number line. So this question had a second part, which is to list down all the prime numbers. Okay, 42 divided by 5 is actually equal to what? 7. 8.4. Okay, so we've got these as our prime numbers. Okay, I've got a request for question 9, which I am not going to go through now because I need to move on to 3.4. I'll come back to this if I have time. So 3.4. is on applications. Basically, everything is the same for us. Everything is the same, but you need to create your own inequality now. Let us take a look at try it 10. Okay, read the question. She has $70 in a box, save 40 every month, minimum number of months for her to have more than 500. Okay, so if we recap, when we have problem sums like this, we let x be whatever we want to find out eventually. So let x be number of months. Okay, in this case minimum, right? Minimum number of months. Complete months, okay? Okay, so now I need to form, instead of an equation, I need to form an inequality. So an inequality will look like this. Can you fill in the blanks? Left side, right side inequality. What do we put in?
70 plus 40x
70 plus 40x
greater than 500.
more than 500. Is that all? More than or equal to? Did it say? So more than or equal to or more than? Be very careful. So this is our inequality, right? Can you do this? Could you have done this by yourself? Yes, right. It's not difficult. So you can do this. I'm sure you can do the next part yourself already. This is the part that demonstrates that you have learned inequalities in secondary school. You did it like that, I can't tell. You do it like this, I can tell. Okay, so 40x is greater than, now I want to compare with the working on the board, 500 minus 70. Does it look similar? Okay, 40x greater than 430. So what do we do next? X greater than 430 divided by 40. X must be greater than 10 and 3 over 4. Am I right? So minimum x is 11. Okay. Now, if I have another question, a separate question that resulted in x greater than 10 and 1 over 5, for example, what would your answer have been? X is 11 still. But if you had done it this way on the board and you arrive at x, you're working blah 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 equals to 10 and 1 over 5. Some people will do this. They may be wrong. Okay? This is not a rounding question. This is a question that requires you to state, in this case, integers, whole numbers. Okay? That's our question. Try it 10. Okay, next. Your turn. Try it 11. They want range of score for the third paper. Okay, so let x be the score. Let x be score for third paper. Let us say that the mean is more than 60, less than equal to 75. Okay, something is more than 60. More than 60, but less than or equal to 75. Does this make sense to you? Right? Okay, we are reinterpreting the question. So what goes into this box?
57 plus 89 plus x
Divided by 3. Okay, so here we have our mean. Our mean is greater than 60, but it is less than or equal to 75 in order to get C, a C grade. So here we work it out. This one of it. This is another one of it. Okay. So in red, I've got 180 less than 126 plus x. In green, I've got 126 plus x less than equal to 225. X is less than or equal to 99. X is greater than 54. So we combine them. X less than or equal to 99, greater than 54.